All right, what I'm doing here today is I'm actually wiring up my FM50 VFD to allow my South Bend CL145C to actually run off of single phase power. Now what I've done here is I had to pull the motor out. I had to change the motor windings in order to make it compatible with the 220 volt three phase. This motor was wired up for 60, so I had to go in and change the motor contacts on that. And I've made some posts in my forum where on a Practical Machinist talking about rewiring this motor. So basically what I have is I had luckily inside my motor there was a diagram that showed how the different terminals were broke out on the machine as far as the motor is concerned. So that's really good. It's a 2 horsepower motor, 1750 RPM is what it's spec'd at, 1730 actually. And what I've done is I've actually got it temporarily connected up here just to make sure that I've got everything connected up on the VFD correctly before I actually go into putting it back in the machine. So what I've got here is I've got 220 volts supplied through a circuit breaker here. Obviously got the panels off just to hook it up, and come across that conduit there on the top, and everything's fully enclosed. And then on the actual box itself, it goes up into the box, and I've got the box mounted on the wall. So there you can see the actual VFD on the wall. So what I'm going to do now is I've got a rotary disconnect switch on this thing so that it can actually be safely disconnected at the box. When you're not using this machine, you can actually turn it off here without having to worry about controlling anything else. Right now I don't have any external controls configured. All I did was hook it up. The directions on this thing were a little bit confusing because if you look in the manual, it's labeled, you have L1, L2, and L3 are your inputs for your power, and T1, T2, and T3 are your outputs for your motor. But if you look at the book, it says that L2 is the neutral. But if you look on the case, it actually says that L3 is the neutral. And also, as you continue to read in the manual and look, and a lot of regular 220 motors are wired this way, they don't run the neutral, they just run a ground. So what you have is you have two hots and a ground. So what I've done is I've actually wired my system that way. I did run a neutral over to this box just in case I wanted to run a 120 circuit in here for whatever reason going in the future, whatever that may end up being. So what I've got right now is I've got two wires coming off of the rotary disconnect switch, and that rotary disconnect switch is actually wired in with two regular 110 volt lines. Obviously it's just a double 220 volt feed. Goes into L1 and L2, and you don't hook up anything else on there except the T1, T2, and T3 in this situation just for testing. Eventually I'll have in the middle of that, just to the left of the left white wire, there are two terminals P and R. That's for the braking resistor, and I'll get into that in a little bit. And in the very back you can see there's a grounding terminal. And what I've done is I've brought a solid ground off of my panel, off of the ground that feeds back. So I'm running a universal ground throughout my shop so that everything's on the same ground plane. We don't want a difference of potential there that could potentially cause some electrical problems for you, and also you could actually get shocked on that if you're not careful. So what I've done is I've actually got everything going back to a common ground, and that common ground is and then now been extended into this box, and I actually have it terminated here. It comes up through the feeder for the voltage and terminates here, and then I go from here back to the box, and that grounds the box with the system. So now, obviously with the door closed, there's a rotary disconnect button on the front. I've also covered that part of my build. Now I'm going to turn the power on. That allows me to put power to the VFD. And I've gone through and done some basic configurations on this. I changed the frequency a little bit. If you look at the settings on this thing, right now, because I don't have my braking resistor hooked up, I've actually got the settings inside this thing pretty much default, except for I bumped the frequency up a little bit, the carrier frequency, which is F12, because the high pitch whine in the motor was a little bit more than I wanted to tolerate. So I didn't go all the way out to 10. I read some stuff on the forum that talked about on Practical Machinist that said that puts a little bit too much heat in the system, so I don't want to do that. I've also set the deceleration to on that's F14. Right now I've got it free run to stop. I'm going to change that once I get the braking resistor set up. That's going to be F15, 16, and 17. I'll cover that as well. And that'll actually be the DC braking time, braking frequency, and the braking level. And I've got a pretty good sized braking resistor, and it's up to 3 horse. This is only a 2 horse motor, but the braking resistor I bought was actually for a 3 horsepower system. It looks very large. And actually, I had designed this to go in the box with the frequency controller. But after going and looking at everything, and I finally decided what I'm going to do is I'm going to put it down in the base of my lathe, underneath, out of the way, so it doesn't get any type of moisture or anything on it. It's just a big resistor, so it's not going to hurt it at all. And I've got nice heavy gauge wires that are going to come back to those braking terminals so that we can do the braking like we need to. So what I'm going to do now is I've got this set up. I did overdrive this a little bit just to play with it. I've got the default start frequency set to 60. And I've got the upper limit right now. I've got it jacked up to 90, but I've just run it up to 70 just playing with it. And I have run it down to about 15 just to slow it down. So I'm going to start it now. You'll be able to see it and hear it running.